For number 15, we have that the function f has a Taylor series about 2 that converges to f of x for all x in the interval of convergence. The nth derivative of f at x equals 2 is given by this formula for anything from the first derivative on. So this finds f prime and on. And they gave us f of 2 equals 1. So we've seen this quite a few times now. Write the first 4 terms and the general term of the Taylor series for f about x equals 2. So just build it first. Let's just say f of x equals, we're around x equals 2. So f of 2 plus f prime of 2 times x minus 2 plus the second derivative at 2 times x minus 2 squared over 2 factorial. What do we need? The first 4 terms. So 1, 2, 3, plus the third derivative at 2 times x minus 2 to the third over 3 factorial, plus dot, 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 plus the nth derivative at 2 times x minus 2 to the n over n factorial, plus dot, 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 make it infinite. And then you can plug in the numbers that you have, and remember, simplifying is optional here. So f of 2 is given to us as 1. F prime of 2, we've got to plug that in. So let's see, when we plug in 1 for f prime. So when we plug in 1, we get 2 factorial over 3, and then it's times x minus 2. When we plug in 2, we get 3 factorial over 27 times x minus 2 squared over 2 factorial. When we plug in 3, we get plus 4 factorial times x minus 3 to the fourth over 3 to the fourth, right? 81. You could also just write 3 to the third. Oh, wait, what did I just do? 3 squared. This one's 9. Sorry, I had 3 in my head. Back to the second derivative, first derivative, second derivative, third derivative. We're not putting in 3 to the fourth. We're putting in 3 to the third. Anyway, you could write 3 squared, 3 to the third, or you could simplify them. And then this is times there we go. Get my exponents right. 3 factorial plus dot, 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 plus, and then for the nth derivative, I'm going to put in n plus 1 factorial over 3 to the n times x minus 2 to the n over n factorial plus dot, dot, dot. All right, so I caught that I was making a mistake because I realized somewhere like there should be a pattern, and I had like skipped a pattern somewhere. So always double check your terms and make sure if you see repeated numbers or if something got skipped that you double check that you didn't mess up somewhere. Okay, that's all we had to do for part A. I've got 1, 2, 3, 4 terms and the general term. Part B is find the radius of convergence. Show the work that leads to your answer. So for a radius of convergence, we should be doing the ratio test on the nth term. So the limit as n approaches infinity of, remember, it's the n plus 1th term over the nth term. So now I know that I could simplify these, but let's just say we didn't. Just make this n plus 2 factorial times x to the n plus 1 over 3 to the n plus 1 times n plus 1 factorial times the nth term, the reciprocal of the nth term, which will be 3 to the n times n factorial over n plus 1 factorial times x minus 2 to the n. Before you take the limit, simplify that. Don't just slash a bunch of stuff out here and call it a day. You want to rewrite after you've slashed some things. So here I will say n plus 1 factorial will cancel and leave you with n plus 2. N factorial will cancel down here and leave us with n plus 1. X minus 2 is what that should say to the n plus 1. So this is going to be x minus 2 to the first, and we're going to have over 3 to the first. And then when I take that limit, I get the absolute value of x minus 2 over 3, since the n's go to 1. And this series would converges by the ratio test if x minus 2 over 3 can stay between -1 and 1. We need to find the radius of convergence, which means get the x minus c expression by itself, so multiply by 3 to the other side. That tells me that the radius of convergence is equal to 3. And we were not asked to find the interval of convergence, so we don't care whether or not these two endpoints are included. So that's it for that one. Let g be a function satisfying this. G of 2 is 3. G prime of x is equal to f of x for all x. Write the first 4 terms and the general term for the series for g about x equals 2. So again, build it first. We're centered around 2, so we start with g of 2 plus g prime of 2, excuse me, times x minus 2, plus the second derivative at 2 times x minus 2 to the second over 2 factorial, plus the third derivative of g at 2 times x minus 2 to the third over 3 factorial, plus dot 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 plus some nth derivative at 2 times x minus 2 to the nth over n factorial, plus dot dot dot. Now let's rewrite this in terms of f. Well, we know that g of 2 is 3, so that's fine. When we say g prime of 2, we really mean f of 2, because it says g prime is equal to f of x. So g prime of 2 is f of 2 times x minus 2. Everything gets knocked down by a derivative. G double prime of 2 is f prime of 2 times x minus 2 squared over 2 factorial, plus f double prime of 2 times x minus 2 to the third over 3 factorial, plus dot 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 plus. So g, the nth derivative of g is the n minus 1 derivative of f at 2 times x minus 2 to the n over n factorial plus dot dot dot. And then let's fill in this information. So f of 2 is equal to 1. So now we have 3 plus 1 times x minus 2. F prime of 2. I'm looking at my f of x right here just because I can't easily see this. You can use this formula again if you're worried you messed up here, or I remember that I caught my mistake. So you can use these. So f prime of 2 was 2 factorial over 3 to the first times x minus 2 squared over 2 factorials. Those will cancel. The second derivative was 3 factorial over 9. There's an extra 3 factorial down there and an x minus 2 to the third. 1, 2, 3, 4 terms we have, plus 0, that's a dot plus. Now the formula, I do want to plug in n minus 1 here. So instead of n plus 1 factorial over 3 to the n, it's n minus 1 factorial over 3 to the n minus 1 times x minus 2 to the n over n factorial plus dot dot dot. Do I need to simplify this? I don't have to for credit in part C. I can to make it easier to work with, but I don't need that yet, so I'm not going to worry about it. All right, and then part D. Does the Taylor series for G as defined in part C converge at x equals -2? Give a reason for your answer. So remember, we had this radius of convergence for F. That was a radius of convergence of 3. And g of x is built upon those f of x values. So I have a feeling we could probably get away with still using that radius, but I'm not 100% certain. But I do know that ratio test will always work to help me find an interval of convergence. So let's just do a quick ratio test. We have an nth term anyway. And so maybe I will simplify this. Simplified, maybe before I do this, the nth term is the n minus 1 factorial cancels out with the n factorial. So each term should just be x minus 2 to the n over 3 to the n minus 1 times n. And so when I do my ratio test on that, I get x minus 2 to the n plus 1 over 3 to the n plus 1 minus 1 times n plus 1, multiplied by the reciprocal of this nth term. All right. And then what are we left with when we cancel stuff out? So we have x minus 2 to the first times n over 3 to the n minus 1 over 3 to the n. You're left with 3 to the negative 1, so put a 3 down here, times n plus 1. And that leaves us with absolute value of x minus 2 over 3. So yeah, I got to the same place. Like I said, I kind of thought I could probably do that, but I think just to be safe, you've got time on your AP test to, you don't have to rush through these. You don't want to sit and ponder for a long time, but you've got time to do things thoroughly. This converges by the ratio test if we stay less than 1. So I'm going to write that down. So if negative 1 is less than x minus 2 over 3, which is less than 1, which means x minus 2 stays between positive and negative 3. And if we solve for x, if we add 2, we get that x would be anything between negative 1 and 5. So x equals negative 2 is not in the, I'm just going to say radius of convergence, because I'm not sure about these endpoints. I don't want to call this the official interval. I'm not sure if that matters or not. X equals negative 2 is not in the radius of convergence. So g of x doesn't converge. The series, for g of x doesn't converge to g of negative 2 at this point. Doesn't converge to, not g of negative 2. Let's just call it g of x. The series for g of x doesn't converge to g of x at this point. All right, that finishes up number 15.